7.6, it's L'Hopital's rule and growth rates of functions. A little bit of review here. They want us to find the limit as x goes to 0 of e to the 2x minus 1 over x sine of x. And we attempt to plug it in, and we find out that we're going to get e to the 0 is 1, minus 0 minus 1, 0 over sine 0, which means we can employ L'Hopital. So now I take the derivative of the top, which gives me 2 e to the 2x minus 2. And the bottom is a product rule, the first times the derivative of the second plus the second times the derivative of the first. And now when I plug it in, I get 2 e to the 0, that's 2 minus 2, I get 0 over 0 again. So I have to employ it one more time. This would now be 4 e to the 2x over, okay, the first piece down here is a product rule, the first times the derivative of the second, plus the second times the derivative of the first, and then the derivative of the sine is the cosine. And so now if I stick it in, I get 4 times 1, 4 on top. And down here I get the first piece is 0, cosine of 0 is 1, plus cosine of 0 is 1, 2, and so the answer is 2. Part B. This was part A. Part B, they want us to take the limit as x approaches 0 of 3 to the x minus 1 over arctan of x. If I stick in the 0, I get e to the 0. 1 minus 1 is 0 over, when is the tangent 0? At 0. So I'm going to use L'Hopital. The derivative of e to a variable, or 3 to a variable, was 3 to the variable natural log of the base over the arctan is the 1 over 1 plus u squared. And now if I plug in 0, 3 to the 0 is 1. I get natural log of 3 over 1, so natural log of 3. Part C. Now we're going to infinity. And if we stick infinity in there, we actually get infinity over infinity. So we can use L'Hopital on this. The derivative of x is 1, the derivative of the natural log is 1 over x. That simplifies to x, and as x goes to infinity, you get infinity. Then we have the indeterminate forms. These indeterminate forms are new to us. It's when you get 1 to the infinity, or 0 to the 0, or infinity to the 0. They're not always what they appear to be. So we're going to look at example 2, and it wants us to find the limit as x approaches 0 from the right-hand side of x to the x. Now, we did something very similar to this before. If you stick in 0, you're actually going to get 0 to the 0. So the first thing we need to do, and I don't really care for the way they write it, we're going to change this to y is equal to the limit as x goes to 0 from the right-hand side of x to the x. And then the only way to get an x out of the exponent is to put a natural log through. And that gives me x, let me write it out, natural log of x to the x, which then turns into x, the natural log of x. Now it has the form, if I stick 0 in, of 0 times infinity. So I can fix this if I rearrange it a little bit and keep carrying this natural log of y down so you don't make a mistake. I lost my little plus signs. Okay. Let's rewrite this as natural log of x over 1 over x, because now when you do that, you're going to get infinity over infinity. So you can use L'Hopital on it. And so I have the limit as x approaches 0 from the right-hand side of 1 over x over, this is going to be negative 1 over x squared, which then just turns into negative x. And as x heads to 0, you get 0, so the natural log of y is equal to 0. But now you have to undo what you did, so how do you get rid of the natural log? Its inverse would be e. The natural log and the e cancel, you just get a y, and e to the 0 is 1. So there's part A. I'm thinking I might be able to do part B in this second column here. The problem with these is you have to keep rewriting the y in front so you don't lose track of what's happening. So this one is the limit as x heads to infinity of 1 plus 1 over x to the x. I'm going to do the same thing. I'm going to make it y is equal to that. I'm going to put a natural log through. Now this time I'm going to save a little paper. By putting the natural log through, it's going to pull the x in front. Because if I stick infinity up in here, I get 1 over a huge number is 0. I get 1 to the infinity, which is our first type. Now if I stick infinity in there, I get infinity times the natural log of 1, which is 0. So I'm going to rearrange it to make it one of the ones that I know how to do. I'm going to pull the x underneath, so it's going to be natural log of 1 plus 1 over x over 1 over x, which then turns it into a 0 over 0. Is that a 0 over 0? Yeah. So now I can use L'Hopital on it. Natural log of y is equal to the limit as x approaches infinity. The derivative of the natural log is 1 over the junk times the derivative of the junk, which would be a negative 1 over x squared, all over a negative 1 over x squared. Those two pieces cancel. And so all I really have left is this. If I stick infinity in there now, I would get 1 over a huge number is 0. 1 plus 1 over 1 plus 0 would be 1. Now you have to get rid of the natural log, so you put an e through. The e and the natural log cancel, and y is equal to e. So my limit is e.